Hello. With this video, I'd like to begin our next unit in chemistry, which comprises two chapters, Chapter 1 on matter and change, and Chapter 3 on atoms, the building blocks of the universe. The first section of Chapter 1 describes how chemistry is a physical science. Not a whole lot interesting in there, so I'm going to go ahead and skip it. Chapter 1.2 is about matter and its properties, and much of this video is going to be concerned with definitions of types of matter, properties, and changes. Much of this you've probably seen before in previous science classes, but bear with me. What is the definition of matter? You probably know matter is anything that has mass and occupies volume. What is the basic building block of matter? That's pretty much what this course is all about, and that is the atom. An atom is defined as the smallest unit of an element that maintains the identity of that element, meaning that if you chop it into something smaller than an atom, it's still matter, but it is no longer that element. What is the definition of an element? An element is a pure substance that is made up of only one kind of atom, and it cannot be broken down into anything simpler or more fundamental. That's why it's called an element, because it is elemental. A compound, on the other hand, is also a pure substance, but it's formed when atoms of two or more different elements combine chemically, that is, when they form chemical bonds. And a compound, in contrast to an element, can be broken down into simpler stuff, namely the elements that make it up. Let's talk about changes, and we're going to distinguish between physical changes and chemical changes. A physical change is a change in a sample of matter that does not involve a change in the identity of the substance. If I carry out a physical change, I'm not turning it into something else. I'm simply changing the shape or the structure. For example, boiling water doesn't turn it into anything else. Melting wax, cutting something, or grinding. These are all examples of physical changes. On the other hand, a chemical change is a change in which one or more substances are converted into different substances, new forms of matter, by rearranging atoms. A chemical change is a chemical reaction. You convert one or more forms of matter into different forms of matter. And examples of this would include combustion, corrosion, digestion, or decomposition. Now let's talk about properties. What is a property of matter? A property is a characteristic of a sample of matter that you can observe or measure. So it can either be qualitative or quantitative. Now, extensive and intensive properties are somewhat different. An extensive property is a property that depends upon how much stuff you have in your sample. Okay? Whereas an intensive property is the same whether you have a small amount or large amount. It doesn't depend upon how much you have. Examples of extensive properties would be mass, volume, energy content, because all of these depend upon how much matter you have. But intensive properties would include color or density or boiling point. Those properties are the same whether you have a very small sample or a very large sample. Now let's distinguish between physical properties and chemical properties. A physical property is a property of a sample of matter that you can observe or measure without changing the identity of the substance. You don't have to turn it into something else in order to observe that property. So for example, I can measure the boiling point of a liquid without turning it into something else. I can measure the density. I can measure the mass. But a chemical property is different. It's a property of a sample of matter that can only be observed or measured by changing the substance into something else. Really, a chemical property is a description of how the substance reacts chemically. So, for example, the flammability of gasoline. I don't know that gasoline burns until I light a match to it and observe it undergo a chemical change. Likewise, I don't know that iron can rust in the presence of oxygen until I actually carry out that chemical change. Now, let's talk about substances. A pure substance is a single type of matter, and it can either be an element or a compound. And here's the crucial description of a pure substance. All samples of a pure substance have exact same characteristic properties and composition. So for example, if I have water, water is a compound that is a pure substance because it's only a single type of matter. It doesn't matter whether that water came from the polar ice caps of Mars or the bottom of the Indian Ocean. If it is pure water, both samples will have the exact same properties, boiling point, melting point, etc., and the exact same composition. That's what makes it a pure substance. Carbon dioxide is a pure substance. It's a compound. Ruthenium is a pure substance. It's an element, one of my favorite elements, by the way. On the other hand, a mixture is a blend of two or more pure substances. Okay? And unlike a pure substance, mixtures can have varying properties in composition. So for example, if I say salt water is a mixture of two pure substances, sodium chloride and water, but simply saying salt water doesn't specify the composition. It could be very salty or slightly salty, and as a result, it doesn't specify the properties. Now, two types of mixtures would be a homogeneous mixture, the prefix, oh, I misspelled that, that's funny. Let's see if I can change that. Okay, homogeneous mixture, let's make that capital, okay? Homo, the prefix means the same. That is a mixture in which the components are dispersed evenly on a molecular level, so the mixture is uniform throughout. Salt water, for example, is a homogeneous mixture. Heterogeneous, on the other hand, hetero meaning different, the components are not dispersed evenly on a molecular level, so the mixture has regions with different properties. Okay? Concrete, for example, if you look very carefully at concrete, you can see that it is a mixture, but it has regions with different properties. It's not uniform throughout. Now, if I want to separate a mixture into a pure substance, I have to use physical methods. So for example, if I take salt water and allow the water to evaporate, I will have separated the water from the salt. Or if I have, for example, a slurry of coffee grounds in hot water and I want fresh coffee, I can filter it, or any physical separation. But if I want to separate a compound into its elements, remember a compound is made up of two or more elements chemically combined by having atoms of different elements chemically bond to one another, I have to use chemical methods. For example, decomposition or electrolysis. And in class, I will demonstrate electrolysis of water, turning it into the constituent elements that make it up. So let us summarize. Here is our general classification scheme for matter. All matter, that is anything that has mass and volume, is either a pure substance or a mixture. A pure substance is a single type of matter. All samples have the exact same characteristic properties and composition, whereas a mixture is a blend of two or more pure substances that can vary in properties and composition. If it's a pure substance, it can either be an element or a compound. An element is made up of a single type of atom and cannot be simplified any further, whereas a compound is made up of atoms of two or more different elements that are chemically combined. A mixture can either be homogeneous if it is uniform throughout, or it can be heterogeneous if different regions have different properties. Okay? If I want to convert a pure substance into a mixture or vice versa, I use physical methods. If I want to convert an element into a compound or vice versa, I have to use chemical methods. So there we have our classification scheme for matter.